Let's solve a problem based on analyzing resistors connected in series and parallel. Here we have got 4 resistors and they are connected to a 120 volt battery as shown in the diagram. Calculate the equivalent resistance of R1 and R2. So there are 4 resistors R1, R2, R3, R4. In the first part they are just asking us to calculate the total resistance for R1 and R2. So if you look at the diagram, we can see that R1 and R2 are parallel to each other because the current is going to split. So the formula for total resistance for parallel is 1 over R total equal 1 over R1 plus 1 over R2, 1 over 80 plus 1 over 80, because both R1 and R2 are 80 ohms each. We get the answer as 1 over 40. But we need to flip, because the formula gives us 1 over R total. We need to flip it and get the value for R total. So in this case it will be 40 ohms. Then we do it for R3 and R4. Again R3 and R4 are parallel. We substitute the numbers into the formula. We get the answer as 1 over 20 for the formula, but then we need to flip it so that we can get the value for R total, which is 20 ohm. Next is asking us calculate the equivalent resistance of the circuit. That means for the total circuit, how to get the equivalent resistance. So what we are going to do is we are going to redraw the circuit diagram. R1 and R2 are combined to give you 40 ohms. R3 and R4 are combined to give you 20 ohms. And both of them are connected in series to 120 volt battery. So now this is in series. So we are going to use R1 plus R2, which is 40 plus 20, which is going to give us 60 ohms. Next, 2 resistors are connected in a circuit as shown below. A metal wire of negligible resistance is now connected between points 1 and 2. Complete the table below. So if we look at the diagram carefully, there are 2 resistors, 35 ohm and 15 ohm. And then there is 10 volt battery. They are telling us a metal wire of negligible resistance. The meaning of negligible is very low. That means almost 0. So between 1 and 2 we have got 35 ohm resistor. We want to remove it and we want to put a wire. So this 35 ohm is removed, and instead of that we are going to put a piece of wire there between 1 and 2. So in the table it's asking us to get the values for V1, V2 and ammeter after connecting the metal wire. So V1 is connected across a metal wire which has 0 resistance. That means it's going to give us 0 volt. So that's our first answer there, 0 volt for V1. V2 is connected across 15 ohm, and because we removed 35 ohm and now only 15 ohm is there in the circuit, that means it's going to get all of the battery voltage, which is 10 volt. So that's our second answer, 10 volt. Then we want to find the ammeter reading. So now I have redrawn the circuit. You have got one battery, one resistor, and we want to find what's the ammeter reading. So we'll use I equal V over R, which is 10 over 15, which gives us 0.67 ampere. A motor is connected to a 12 volt battery as shown in the diagram. How much power is delivered to the motor? So in the diagram we have the value for voltage, we have the value for current. Power is given as VI. We substitute the numbers, we get the answer as 18 watts. Next is asking how much energy is transformed if the motor runs for 15 minutes. Now it's not seconds, minutes, so we'll have to convert it. Energy formula is power multiplied by time. Time is 15 minutes multiplied by 60 to get the answer in seconds, which is 900 seconds. Then we just put the numbers into the formula and we get this as 16,200 joules. So what we need to remember here is if the time is given in minutes, we want to convert that into seconds. Toaster is connected to the circuit as shown in the diagram. What is the resistance of the toaster? So we have got the value for voltage and the current from the diagram. We will apply the formula V equal IR. Voltage is 120 volt. I is 4.2 ampere. We substitute that into our formula and we get the answer for resistance as 28.6 ohms. At what rate does the toaster transform energy? Now, this is not asking you like directly to calculate a specific quantity. It's saying at what rate. So rate of energy is another name for power. So they are asking us to calculate what's the power. So remember, if they say rate at which energy is being transformed, that means they are asking us to calculate the power. Power is VI. We substitute the numbers into it. We have the voltage, we have the current, we get the power as 504 watts. So here we need to remember the word rate of transforming energy means they are asking for power. A parallel circuit has four branch currents, 120 milliamperes, 250 milliampere, 380 milliampere and 2.1 ampere. How much current passes through the power source? So let's just quickly draw a parallel circuit diagram. This is how it would look like if they had given a diagram. We have got four branches. There are four currents passing through it, each branch. We want to find what's the current in the power source. That means we want to find the I, which is labeled in the diagram. So we know that the conversion we have to use here, milliampere, has to be converted to ampere. We have to multiply that by 10 to the power -3. And then we know that we have to add up all the currents to get the total current. It's a parallel circuit, so we'll add up all the currents. Do not forget to convert milliampere to ampere, and that gives us the answer as 2.85 ampere. Another question, this time it's a series circuit which has 4 resistors. The current through one resistor is 810 milliampere. How much current passes through the power source? So again, if I draw the diagram, this is how it would look like. It tells me the current through one resistor is 810 milliampere. In series, we know that the current remains the same. That means the same current passing through all the resistor, and that's also the total current. That is the current for the power source also. So in series, same current flows through all resistor. Current through power source will also be 810 milliampere.